Okay, these are our notes for section 3.2 on solving systems of equations using substitution. That's the second method of solving a systems of equations, and this is going to be using algebra. This is one of the two ways to solve a systems of equations algebraically. The other way is elimination. This way is substitution. And what we're going to do for substitution is we're going to substitute one equation into the other. And there's 4 steps to doing this. The first step is to solve one equation. It doesn't matter which one you pick, but you're going to solve one equation for a variable. And you want to look and see which one's going to be the easiest to solve for. That's going to save you the least amount of work. Okay, but you pick one equation and you solve for a variable, which means you want to get it so that it's like x equals something or y equals something. Everything else is on one side of the equal sign. Step 2, we're going to substitute or replace. That's another way of thinking about it. We're going to replace whatever variable we solved for with the equation. So we're going to substitute into the other equation. Step 3 is we're going to take, and we have to solve that on step 2. I forgot that. You need to solve it for your variable. Step 3 is we're going to take that answer that we got in step 2, take the answer, and plug it in to one of the equations. Okay, so at this point in step 2 you should have a number for an answer, and in step 3 you should get a number for an answer. So you should have 2 separate numbers here. The first variable should be in step 2, and then the second variable should be in step 3. Now in step 4, you're going to write your answer. And usually that's going to be as a point. Okay? If you have 2 variables and you have 2 numbers in there, you want to make an ordered pair out of it, because that's where those lines are going to intersect. So it may be x, y. If you have something other than x and y, say you have a and b, you put whatever letter comes first in the alphabet first in your ordered pair. Since a is first in the alphabet, it'd be a comma b. Now remember, we're going to classify these also, and we could have consistent, independent, consistent, dependent, or inconsistent. Okay, consistent independent means one answer, one solution. Consistent dependent means many. And inconsistent means none. There is no solution to that problem. Well, here's our example. We've got x plus 4 equals, x plus 4y equals 26, and x minus 5y equals negative 10. So our first step is to pick an equation and solve for a variable. Now if we look at this, those x's, there's nothing in front of them. They're going to be the easiest variables to solve for, because all we have to do is either add or subtract the y term to the other side. Well, I'm going to pick the first one here, and I'm going to get it so that it's x equals. So over here we've got x plus 4y equals 26. We're going to subtract 4y on both sides. Now you could solve it for the other one. You're going to get the same answer. You could solve the second equation. I'm just using the first one because it comes first in our problem. So x equals negative 4y plus 26. Step 1's done. We solved an equation and we got it. So a variable x equals everything else. Step 2 says we're going to substitute what we got on step 1 into the other equation. Well, here's the other equation. X minus 5y equals negative 10. So every place we see an x, we're going to substitute in or replace x with negative 4y plus 26. Well, that's the first thing I have here. So it becomes negative 4y plus 26 minus 5y equals negative 10. Now we're going to combine like terms. I got negative 4y minus 5y, that's really negative 9y plus 26 equals negative 10. Now we're solving this. Subtract 26 from both sides. Negative 9y equals negative 36. Divide both sides by negative 9. Y equals 4. That's the end of step 2. we've got our variable, one of the variables, to be a number. Step 3 says we're going to take that answer and plug it back into one of the two equations, one of the two original equations. I'm probably going to pick the first one because the second one has negatives in it. I could plug it into the second one, though, and I would get the same answer. So this was step 1, step 2, step 3. We're going to switch out all the y's now for 4's. So x plus 4, now it's times 4 because that's where our y was, equals 26. It's really x plus 16 equals 26. Subtract 16 from both sides, so x is 10. Now step 4 is to write our answer. Well, x comes first in the alphabet, so it's going to be 10, comma 4. That's our ordered pair, x, comma y. Now we have one answer here. If we think back to our classifications, that means it's consistent, independent. Okay, so we've got our answer and we've classified it. I've got a pause and practice problem for you here. It is 2x minus y equals 2, and 6x minus 3y equals negative 12. Pause the pen cast, work it out, unpause it, and check your answer. Alright, now that you have worked it out, let's work it out together. We've got to solve one of these equations for one of the variables. And if we look here in the first equation, that negative y, there's a 1 in front of it. So that's probably going to be my easiest one to solve for. I could solve for any of them, though. But I'm going to solve for that y. So let's rewrite it down here. This is step 1. 2x minus y equals 2. I'm going to subtract 2x from both sides. So negative y equals negative 2x plus 2. Can't have a negative in front of the y. Divide everything by negative 1. So y equals 2x minus 2. Good. Step 1 is finished. We've got a variable to equal everything else. Step 2 now. We have to take that and plug it into the other equation. Now it's important you plug it into the other one. You can't plug it back into the same one because it won't work. So we're going to plug it into the second one now. 6 times x minus 3. Now in place of y, we're going to put 2x minus 2 equals negative 12. Now to simplify this, we have to distribute that negative 3 through. 6x minus 6x, because negative 3 times 2x is minus 6x. Minus 3 times minus 2 is positive 6, equals negative 12. Simplify, our 6x's cancel, and we end up with 6 equals negative 12. Now, is that a true or a false statement? Well, that's a false statement, and we've talked about this before. It's a false statement, which means there is no solution to the problem. And if we think up to our classifications, consistent independent meant there was one answer, one solution. Consistent dependent, many solutions. Inconsistent meant there were no solutions. There was no answer to the problem. No solution here. That means we're going to classify this as inconsistent. And there's our answer to the problem. We should have got inconsistent. Now you could have solved it a different way for a different variable, but you still should have gotten inconsistent as your answer. You will get a false statement no matter how you solve it. And those are your notes for section 3.2 on substitution.